All right, so let's consider the situation where you've been given 2 points. So say you've been given the points 3, 2, 3, 2. Let's say we'll call that point A. And then let's also say you've been given the points, or on a coordinate plane, right? You've been given the point B, and point B has a location of 4 and 4. So this one's at a corner here. And you've been given the question, what's the slope of this line, right? Draw a line between these 2 points and then find the slope. Now you could do that. You could graph the points on a graph and draw the line and try to figure out what the rise over run is. You can figure out how far it changes in X versus Y, right? But there's actually a quicker way than drawing out a graph on your own and having to then figure out how many points to the right it goes, how many points to the left it goes. And we call this the 2-point formula. Okay, this is called the two point because there's 2 points here, A and B. 2-point form or formula. Okay, and it deals with the idea that slope, right? If we think about the definition of slope, slope is the steepness of a line, but it's essentially that measurement. It's a measurement of the change in y with respect to x, with respect to a change in x. Okay, so we can rewrite this a little more, I think, visually pleasing. We could say that that slope is equal to rise over run, right? The rise, which is how high or low or how much it rises or falls, right, on the y-axis, over the run, which is how far it travels either left or right on the x-axis. And this is equal to the change in y, which we can denote as delta y over delta x. And delta is this fun little symbol. It's a Greek symbol that just means change. So you can have a change in time, delta t. You can have a change in a lot of things, right? But in this case, we're talking about the change in y, or delta y, right? Delta y with respect to a change in x, which is the delta x here. Okay, so slope is actually a change in y over a change in x. And we can actually rewrite this just one more time. And a change in y is talking about moving from one point to another point. Okay, at least with the y, right? You're going from one y somewhere on the y-axis, and then you're moving to another point on the y-axis. So we're going to break this up, and I'm gonna color code this up here for you. I'm going to say that this 3 for point A, we're going to call this x1. And then for B, this 4, I'm going to call this x2. And then I'm going to have this 2 here, for A, be y1. And I'm going to call this 4 y2. And what we're going to do is we're going to take the second point and essentially subtract away this A. Okay, and the way we're going to do that is we're going to say the change in y, which is actually just y2 minus y1. That's the change. That's the difference between the 2 points, or at least between the two y-axis points, right? And that is going to be over, the change in x, which can be represented by x2 minus x1. So we've got a change in y over a change in x, and y2 minus y1 over x2 minus x1 is equal to that. Okay, so you're essentially taking the distance traveled from y2 to y1 and x2 to x1. All right, so we can plug this in, right? So let's take this and plug it in. We've got a y2 of positive 4. So for this problem, right, we've got a y2 of positive 4. So that's going to go up here. And we're going to subtract away this y2, which we've labeled as 2, right? Y2, or excuse me, y1, which we've labeled as 2. We're going to put that over our x2, which is another 4. So you see we've got this point B here, 4, 4. And we're going to subtract the value for x1, which was a 3. Okay. So we've got 4 minus 2 over 4 minus 3. And so what we end up with is 2 over 1, which we can simplify down as 2. Okay, so the slope of our line, we can say that this is equal to m, right? This is all equal to m because if we look at our formula for the slope of a line, we have y equals mx plus b, where m is our slope and b is our y-intercept. That's where the line crosses the y-axis, y-intercept. Okay. And so we can say that the slope of the line, which is the coefficient of x, it's the buddy attached to it, is equal to m, and that's what all this equals as well. Okay. So our actual slope for this line, the line created by 3, 2, and 4, 4, is 2. Okay. So we can do that. Let's try 2 more points and let's see what we can get here. So let's take our formula here. And let's say that you were given the points 3, 3. So we'll say point A. We'll say point A is 3, 3. Excuse me, let's do 3, negative 3. That's going to work out better. Let's do 3, negative 3. And then point B is going to be 4, 6. Let's do 4, 6. All right. So those are our 2 points. And we're going to just plug them in to our 2-point formula. Let's label them real fast. We're going to say that this is y1, or excuse me, x1. We're going to call this x2. And then we'll call this guy, let's use blue. We'll do y1 and y2. Okay. And then our formula, right, if you remember, is just going to be y2 minus y1 over x2 minus x1, x2 minus x1, and we're just going to plug it in. So y2 was a positive 6, y2 was 6, minus our y1, which is negative 3, okay? And then our x2, because this is all over, let's use a different color here. This was all over x2 minus x1. x2 was 4. Again, you have the points 6 and 4 there, right? Those are the coordinates for that. And then this is all minus a positive 3. Okay. So if we simplify that, we're going to get 6 minus negative 3. And if you remember this is actually the same thing as 6 plus 3, because when you subtract integers, you actually are adding the opposite. So I'm adding a positive 3. And 6 plus 3 gives me a positive 9. And then I have 4 minus 3, which is just 1. And we can simplify this all down to 9, and 9 is equal to m. Okay. So our slope for the second point is just 9.